Grab an egg out of your fridge and use it to make observations about the way that molecules move. This is an opportunity to observe a cell without needing a microscope. The membrane that lies beneath the shell will permit the diffusion of substances. The white part of the egg, the albumin, is like the cell's cytoplasm. To remove the eggshell, simply place the raw egg in 6 ounces of vinegar so that the acetic acid wears away the calcium carbonate shell. Before doing this, you can involve children by having them make observations about the egg's color, shape, and texture. Encourage them to make predictions about what will happen to the egg sitting in vinegar overnight. Once the shell is removed, the water within the vinegar will have diffused into the model cell. This occurs because the concentration of water molecules outside the cell is greater than the concentration of water molecules inside the egg. The diffusion is a process where molecules move from where there are more to where there are less. After the egg has been sitting in vinegar overnight, it will be visibly larger. Additional observations could be made about the egg's color or texture. A finding of fewer than 6 ounces should result from measuring the remaining liquid in the container. Next, place the model cell in 6 ounces of corn syrup. Make predictions about what will happen to the egg sitting in the syrup overnight. When the model cell is next observed, it will be visibly shrunken. Remove it from the container and measure the remaining liquid. This time there will be more than 6 ounces than was placed in the container. Since the egg is smaller and there is more liquid in the container than was put in, one could reasonably infer that water diffused out of the cell. Finally, place 6 ounces of water in the container and again place the cell back within. What will happen to the egg this time? The following day, the egg will be even bigger than when it started. Measurement of the liquid in the container will be less than 6 ounces. Since the egg is bigger and there is less liquid in the container, the process of diffusion can again be inferred. The concept of passive transport or diffusion is instrumental to understanding the functional role of the cell membrane in survival. Diffusion of molecules is a process that helps cells maintain homeostasis, a major concept in biology. This hands-on activity is a visually striking way to experience this process. We've all seen diffusion in action. Examples include dry fruits and beans swelling when they are cooked, watching produce at the grocery being sprayed so that fruits and veg stay plump, and seeing dehydrated brown plants along roadsides after winter salting. Like plants, mushrooms also use diffusion. Mushrooms have mycelial networks below ground that absorb nutrients. Their exposed surfaces are where gas exchange occurs. Both use passive transport. But because diffusion is a passive process, it only works over short distances. This is why mushrooms' mycelial strands are thin, and also why mushrooms grow rapidly after rain. They use osmotic pressure, a type of diffusion, to pump water into their cells, literally inflating the mushroom like a balloon. You can see this after a rainstorm in our enchanted forest in the Hudson Valley, where we grow oyster and wine cap mushrooms. Visit our wonderful woodland in the Hudson Valley, New York. Contact Pleasant Valley Maple Lodging at gmail.com. Learning exercises related to diffusion, other science concepts, and cross-curricular activities can be found at GCAT's Chronicle on Teachers Pay Teachers and Amazon.